Today on The Future of Everything, the future of human and computer interactions. I don't think I need to tell anyone that computers are everywhere and humans are interacting with them increasingly and everywhere. Now let's think back to the old days when it was through computer terminals, where we sat down at a desk and we typed in stuff. This is the ancient era. And little TV screens showed you mostly text. It was mostly a black screen with like little white green letters. Then a revolution happened when things got more graphical, so we could have white screens with black letters. That blew our minds and was huge. And I'm not really kidding. This was in the early 80s. The mouse emerged. Apple popularized the mouse as a way to interact, borrowing and popularizing technology from Silicon Valley and other innovators. Again, somebody added buttons to the mouse. That was a huge moment. And of course, I'm being a little facetious here. But the fact is that interaction with technologies in early days was driven by very limited interfaces and interface technologies, and a model of a computer as like a very smart typewriter calculator. With the acceleration of computational capabilities, however, both hardware and software provide many less limitations to what we can do. But the freedom that we have now in like designing these systems means we actually need to make decisions about how we want to interact with these systems, and there are not obvious answers. Phones talk to us with a conversational speech. We can yell at our TVs. Many of us have been yelling at our TVs for a long time, but now the TVs actually respond when we yell at them. We can embed computers in the environment around us for sensing and interacting. High-resolution monitors are approaching the same resolution as our eyeballs. They're not there yet, but it is increasingly becoming difficult to tell the difference between a real image and a digital image. AI systems are now allowing software to be smarter, more responsive, and sometimes do tasks normally associated with human intelligence and pretty well. They can identify objects, they can run robots that make decisions during surgeries while cars are driving, etc. So now we have all these choices, and we have to make some decisions about how we want to design the world around us so that this technology winds up improving our lives and not being a big bummer. So what would improve mean? Dr. James Landay is a professor of computer science at Stanford University and an expert on user interface design, cross-cultural interface design, mobile and ubiquitous computing, and the use of technology, importantly, I think, to support behavior change. James, I made a little fun of the way we used to keep computers in a box with very rigid interactions. But now, with the growth of AI, there's an increasing sense that computers have gotten out of the box and escaped, perhaps. And there may be a need to rein them back. How do you approach this challenge of integrating humans with digital technology in a thoughtful way?
So the key to doing this in a thoughtful way is to put people first. So in human-computer interaction as a field, we like to talk about something called human-centered design or user-centered design, which means we don't even start with the technology in mind as much as trying to understand what is the problem we're trying to solve for a particular user population. So, you'll hear the same thing from folks talking about design thinking in the Stanford D School.
Yes.
It's really about finding those user needs. What is the real problem they're experiencing? Often we as engineers think we know the problem, but it's really not the actual problem until you go out and talk to people, observe people, then you find the problem, and then you see what technology you might have that can help you solve it. So it's going to be the same thing with these ubiquitous AI technologies, which is, we might think, hey, we have some new technology, we could detect skin cancer better than a doctor or something like this. But in reality, we want to understand, okay, what's the problem in that current situation? Is doctor making mistakes? Or is it taking too long? Is it hard?
Right.
Is this something somebody needs to do at home? Let's figure that out. And then we start to look at what technology might we bring to bear to solve it.
I'm struck by this because engineers are not necessarily traditionally trained to do the kind of humanistic needs finding, human-centered activities that you're implying have to happen. Engineers are trained to build stuff, or at least that's what they think they're trained with. So it sounds like what you're saying is actually a fairly revolutionary statement Or is it not revolutionary in terms of how engineers have to work?
I'd say it's revolutionary to engineers. To those of us who've been practicing in this field for 20 or 30 years, it's kind of like basic knowledge of how you make things that work for people. Now, in reality, we often do what I would say technology push and technology pull. The traditional engineering is technology push. Hey, I've got this new hammer. Where can we hit some nails? Technology pull is more of, hey, we figure out what the problem is and how to design for people, and we look for a technology that works. In reality, what often happens, especially in the research realm like the university, is we're going both directions, because a lot of us have some new technology we're developing, and then we look for applications where it would make sense. So it would be probably a little dishonest to say it always happens best when we start with users only, but we probably have to go both of those directions, looking at what the real problems are, seeing what interesting new technologies are coming down the line, especially for us researchers. We're looking so it's like 10, 20 years out, right?
You're skating to where the puck will be.
Right, skate to where the puck will be, exactly. Great Gretzky quote.
So, how do you have you and your colleagues in the research domain operationalized and turned it into a science, figuring out the needs of users? Because my guess would be that they can't always articulate where their problems are. Maybe sometimes they can. I mean, what's your observation about if you go into a situation where you have a high suspicion that you could be helpful with some engineering? How much do the users just give you their problems on a plate? And how much kind of hard work is it to kind of deconstruct their world and figure out where the real problems are?
Yeah, so I would say it's not a science. It's more of an art.
Okay.
And this is what makes it kind of hard to teach and hard to be great at. It's not like you can just get a formula and follow these steps and you will come up with the right thing. There are people who have this what I would call design ethnography background, who are trained to observe, to interview, and we call it that because it really comes out of the ethnography from the early 20th century of studying new tribes and other people that haven't been studied before.
Like these dermatologists are a tribe.
Yeah.
And we need to understand what's up.
Right. You need to go into that community and observe them in the wild, i.e. in their workplace where things are happening and with their patients, and see how it's doing. So, we teach students to do this in our introductory human-computer interaction class here at Stanford, but it's something that they're not good at until they've done it in, 3 or 4 classes. And in fact, over in product design in the Stanford Mechanical Engineering Department, they have a whole class just on need finding, how to do that. So it's a skill, but I would say it's not really a science. I try to teach the students that if you go interview 5, 10 people, those aren't scientific results. You're not going to be able to say something statistically. It's more of an inspiration to your design. You found something interesting that maybe no one else had seen that angle. So I see it more as art and inspiration than science.
This is The Future of Everything. I'm Russ Altman. I'm speaking with James Landay about needs finding and human-computer interaction. And like before you build your hammer, you might want to understand your nail. Can you give examples from your work of where you feel like you've been successful at looking at a situation and saying, this is what I think could help the practitioner or the person who has a problem be more effective?
So some of my research has simply been in tools that would help designers be able to apply new user-centered design into new domains. So for example, in a subdomain of AI that we call activity inference, where I want to figure out what a person's doing in the physical world. Like, are you running? Are you walking? Are you going upstairs?
Yes.
We had developed some of that technology early on in a research lab I led in Seattle for Intel. But there was no way a designer could then take that technology and easily develop a new application, let's say track your exercise and give you feedback. So we had made tools that would almost be like a design tool that a designer who didn't have AI or machine learning background could use those concepts and try their design ideas really quickly and prototype new ideas. So that's one area throughout my career where I've tried to enable designers to approach a new technology that's coming out before it would really be accessible to them.
So it strikes me that must be an area that evolved incredibly quickly, because I would guess you were doing this work before a Fitbit existed, before an iPhone, maybe before an iPhone, but certainly before the watch, the Apple Watch. So how well were you able to kind of create these tools did they anticipate the availability of these new technologies, or did they quickly become irrelevant because of the new technologies?
So I would say we did well at anticipating where that puck was going, in that there were no Fitbits, there were no smartwatches per se. There may have been some prototype type things, but nothing like an Apple Watch or a Fitbit. And we had horrible mobile phones at that point. The iPhone and the Android phone came out 2 or 3 years later than that kind of work. But we were right in anticipating that eventually those phones would have the processing power to do the sensing and machine learning on the phone. So when we first did this research, you had your Windows mobile phone in one pocket, and on your belt you had a little pager-sized device that actually had another processor and 10 different sensors, and it did all the machine learning. We weren't perceiving that people were going to wear one of those in the future. We knew that would eventually be built into the phone.
Gotcha.
And so we were right in predicting that, and we saw Fitbit come out, and they actually picked up some of the metaphors that our early design showed, the Apple Watch. But I'm actually still working in this area because I actually think those companies haven't picked up some of the lessons from that earlier research on how to change people's behavior using
Great
feedback.
topic. Yeah, so let's talk about behavior change, because I know that's a big focus of your research, which is we're not just trying to help them do things what they're doing now, but sometimes people have goals to actually change their behavior for health reasons, for performance reasons. Tell me about the behavior aspect of all this.
Yeah, so I've been working in that area for 10 or 15 years, and one of the things that we originally noticed was people were starting to use their phones a lot. Now we know the research shows people pull their phone out of their pocket or purse 100 or 200 times a day and glance at it to just check the time or to see some SMSs or alerts or unlock it and play a game, whatever. And so our idea was, could we take advantage of those glances, those 200 glances, to make people more aware of what their behavior was? We really thought the difference between somebody who was able to stick to a diet or stick to their exercise plan or be more thoughtful towards the environment was being more aware of what you were doing. Some people were more aware, some other people needed help. So what we wanted to do is every time you took a glance at your phone, we were going to give you a way to know how well you were doing with respect to your exercise goals, for example. So in the system called UbiFit, on the background of your phone, these flowers would grow, and every time you exercise, another flower would grow. And the idea was not that you would look at your phone and go, oh, I did 3 runs, 5 walks, and 6 aerobic.
Like it's not a graph.
Right. It's not a graph. It's not quantitative. It's more, hey, the more flowers in my garden, the more I know I'm doing. Towards the end of the week, I might be reaching my goal. So it's glanceable, just to give you almost a imperceptible idea of how well you're doing.
This is the future of everything. I'm Russ Altman. I'm speaking with James Landay now about growing flowers on your iPhone as a proxy for your exercise levels. So that's interesting, because just to deconstruct it for a second, I pick out my phone because it buzzed and I'm getting a phone call, or because I want to check the weather, and in literally microseconds or milliseconds, let's say, I also get a visual cue. And do you expect that cue to be in the consciousness of the person, or is it going to stay in the back but still have subconscious effects on their behavior, or do we even know that yet?
I think it's really an unconscious in the subconscious. You notice it, but maybe not even consciously. Now, every now and then you might notice it and go, oh, hey, that pink flower grew. What did I do there? And then maybe you launch the app and look more at the
or
analytical.
Or things start looking dark and dank, and the flowers start dying.
I really need to take my gym bag today and not drive my car or something like this. So sometimes you might be conscious, but I think most of those glances is an unconscious, and that's what we were trying to get at. And we've also looked at that using, for example, vibration on a smartwatch. Could we send you vibrations letting you know about your performance, and would that cause people to do better than having to look at an image? So we've tried it visually as well as using tactile.
So this is really interesting, and I could imagine that for things like exercise and tracking of activity, that this could work. Let me ask you, what's your how do you think about somebody like me? I might have multiple goals, right? Yeah. So right now I want to make sure I get my exercise, but I'm also writing a grant proposal that I have a deadline for, and let's say there's 3 or 4 other things going on. Do you imagine that we're going to be able to have several of these cues in our life, or are we single channel people, and it will be hard to signal multiple potentially competing behavioral goals through these technologies? How should I think about the evolution of this?
So I think that's an open research problem. I've written proposals about how we might interleave 3 or 4 different variables by showing you, let's say, a different image. Or maybe one image encodes multiple variables. So like the sun moving across the sky represents your exercise, and the flowers represented your
Progress
green
on
behavior. We have not shown which of those work, and we haven't really got to it. In the most recent version of this, in an application we call Huizuki, we actually tried to encode both physical activity and sustainable green behavior in the same interface.
That's two.
That was 2, but we haven't really shown. Can people tell the difference? We're just not there yet. We're still at the point of trying to show that these interfaces lead you to longer-term behavior change, to sticking with this. Because one of the big issues is studies have shown things like Fitbits, a third of the people quit after 3 months. 50% of the people abandon after 6 months. And it's not because, hey, I've suddenly got fit. I've met my goal. It's because the novelty has worn off. And in fact, it starts to become a reminder of what you're not doing that you've committed to. So some really great psychology research here at Stanford with Professor Aaliyah Crum in the psychology department really looks at health mindsets and how can we shape people to have a healthy mindset towards physical activity. And so we're trying to take some of the ideas from Professor Crum's group and put that into some of these activity tracking applications so that you have a positive attitude and will stick with it over a long period of time.
So tell me a little bit more about the Huizuki. Tell me about that. I know that there's a story, and the idea is that there's a narrative that proceeds over time, and presumably this is one of the ways you're going to grab the ongoing attention of the user.
Yeah, so one of the issues that we've seen is, again, abandonment of these devices. So in our prior work, you just saw one image on the background screen of your phone, and that would change over the week. Let's say the flowers growing in your garden, and if you hit your goal, a butterfly would appear. But then on Sunday, it would all start again. As an empty garden, you would start again. And so what we wanted to see is there a way to engage people longer? So what we've done is we've created a narrative arc that goes over 13 different visual chapters, and each chapter you move forward in the chapter, and we actually have a plot and a background and a hero and a bad guy. And
villagers, I'm sure there's villagers.
There's ups and downs, and all these things occur. And the idea is that will keep people engaged over a long period of time. And so, in fact, we've worked with a narratologist here at Stanford. A narratologist, that's a word I didn't know about until a year ago, which is an expert in narrative in the English department, a professor of English who's helping us make those stories more engaging.
You want stories that don't suck.
Right.
Because that draws people in, and you don't have to be an expert on everything. And if there are these narratologists who can tell you this is what makes a good story, then you'll be able to take that and use it for these multiple uses. This is The Future of Everything. I'm Russ Altman. More with Dr. James Landay about human-computer collaboration, interaction, and maintenance of attention next on Sirius XM Insight 121. Welcome back to The Future of Everything. I'm Russ Altman. I'm speaking with Dr. James Landay about the use of technology to basically augment human performance. And one of the areas, James, that you've worked in very actively is smart, intelligent tutors, education. What are the challenges and what are the opportunities there? And I know it connects to your work that we were just speaking about creating compelling narratives.
Yeah, so when I think about this idea of human-centered artificial intelligence, the basic idea is how can we augment people and help them be better at what they do, whether it's being a better learner, a better teacher, a better artist. And so when I think about education, it's not about how do I replace the teacher with an intelligent tutor. It's instead, how do I help a student who maybe isn't motivated by the current school system to be engaged more in learning? So when I see students at a place like Stanford, this is the cream of the crop. But there's a lot of students who the traditional school system probably just bores them, and we're losing that potential. So one of the interests I had was there another way to engage younger children, kind of age 6 to 12, in learning outside of the school day in a way that maybe would get them more engaged in the traditional school? And so we started to think about story. And what we were motivated by was by this 1995 science fiction novel by the author Neal Stephenson. The book he wrote at that time was called The Diamond Age, with the subtitle, that's the weirdest subtitle I've ever heard. It says, or, comma, a young lady's illustrated primer, where a primer is like a British school book. And in that story, the key idea was that there was this tablet computer that this little girl got a hold of that her brother stole from somebody he mugged. And that story on the computer was a narrative. So she would read a story. But as she read that story, she had to learn things in the real world. She had to learn to read first. She had to learn math. She learned physics. She learned stranger danger. She learned martial arts and survival skills, all while reading a story that went on for years.
And the motivation came from her fervent desire to understand what was going on in the narrative.
Right. The narrative is what drew her.
I need to understand physics because this doesn't make sense.
Right. The narrative is what pulled her in, and the story and the characters pulled her in to learn these things. And not just sitting behind a computer in the den. Some of these things you have to learn out in the real world. So when I read this, I was a graduate student, and I thought that was impossible from an AI perspective. The AI just was not there to create this thing. So roll forward, almost 15, 20 years, 2010, the iPad came out. I was living in China on sabbatical, and I saw that device, and I thought, that's the Young Ladies Illustrated printer.
Wow.
That's the hardware. And I started to think about it again, going, okay, could we build such a thing? And software had made a lot of progress in those 15 years that I started to think, oh, we could build it. And then when I got here to Stanford a few years ago, we seriously started the project. And we've been creating narratives that embed fun educational activities and trying them with children. And we iterate with kids and see, oh, is that story too complicated? Is that learning activity too complicated?
And it's very much based on the insights. So now, did this author give you enough to work with in terms of how to motivate the young woman? Is that did he get it right, or have you had to kind of flesh that out because she was a little bit too eager, maybe a little bit too willing to learn things, and that doesn't match reality?
So there's some things in the novel that are good to make a good novel.
Right.
And I did a thing here in maybe 2015 that I never thought I would do as a computer science professor, which was I had a reading group with some undergraduates where we read a novel together, and we actually tried to extract the spec of this device. What were the features that were described? And they're still on my whiteboard in my office. And some of those features we decided, those were just good for a story. So, for example, in this novel, the little girl's mom is always kind of shacking up with some bad guys. And one of them takes the thing and throws it at her head, and it just gently glides down. We're not building that.
Right.
So there's some
So it was
things,
a little bit of metaphysics.
Yeah, there's some things that are just good for the novel. But then there's other things. For example, it can detect her emotion. Okay, we haven't quite put that in our prototype yet, but being able to detect whether a student is actually frustrated or not when you're trying to teach them, that's key. So that's a feature that we will try to build in so that you can understand the state of the mind of the student. And we're also doing a lot with AI in terms of, can you predict what problem you should show a student based on what they've done previously to both challenge them but not challenge them too hard or not make it too easy? There's a lot of research that has been done there, and we're pushing those algorithms into this.
This is The Future of Everything. I'm Russ Altman. I'm speaking with James Landay about this amazing idea of a narrative that motivates learning. Is there an instantiation yet of a story with specific, I guess, learning goals, learning objectives for a narrative?
Yeah, so we're working with people in the Graduate School of Education as well as graduate students there, and we've mapped out some learning goals and objectives, and we've written a couple of short stories. So there's one where you go back in time into the time of ancient Greece, and you're in a village and people are arguing about whether the king's crown is really made out of gold, and then you eventually become the apprentice to the scientist whose name is Archimedes, and you do some experiments with actual water and containers and learn about volume and density and things like this. So, we've tested those with kids, and, they work well for some and not others, and we're trying different math activities as well as science activities and writing activities in these types of stories.
So how structured do you make? So this is great. And so I'm imagining I'm reading and I come upon a set of challenges, and now I realize, I'm the apprentice. I need to learn about volume. Do you have like quizzes where they have to demonstrate the that seems a little rigid to the I've now acquired skill X. How do you allow them to move forward and do this trade-off of you've learned enough that we're going to now expose the next part of the story versus we're going to stall the story until you can measure the volume of a cup of water?
So it's less a quiz than you going through a learning activity. And one of the pieces of advice I got early on in this project from Dan Schwartz, the Dean of the Graduate School of Education, was don't make it such that people can't move on if they can't master something.
Right.
Instead, make it about exposure.
Right.
And I thought that fit well with my idea of exposing kids to these learning concepts in a fun way rather than, hey, you didn't master this, you're stuck at this level. Now, one thing we did do is we've worked a lot on having a chatbot, an AI agent that can help the student when they get stuck. And so you can ask questions. And so again, some of the AI research is how do you train a chatbot on domain knowledge so it can help a student, let's say, learning about volume and not have to hard code rules for every single possibility. Right. So can we learn this material semi-automatically? And so that's, again, some of the research. The chatbot can help the student when they're stuck at that step and allow them to move forward to the next part of the story.
Much as a skilled tutor would know the right question to ask, or have you thought about this, or did you consider this, prompt the students, and then they can make progress.
Exactly.
Well, in the last couple of minutes, I did want to ask you about your interesting work on hybrid physical spaces. This is actually not unrelated to what we're talking about, because you right now you're looking at a tablet, but someday you might be in a virtual world. There might be a world around you where you're learning. How have you approached that problem? Why is it important to you?
Right. So this project, Hybrid Physical Digital Spaces, comes out of this observation that one of my colleagues in civil engineering, Sarah Billington, and I had, which was we spend 87% of our day in the built environment. And the way that built environment is made affects your well-being. It affects whether you feel stressed. It affects whether you're going to get any exercise. It affects your sense of belonging, even in your organization, school. And we thought, well, how are buildings designed? Are they designed to take advantage of this? And we found there's not a lot of good research doing this. So we wanted to first do the research to show how different factors affect those variables of things like stress, creativity, sense of belonging. So natural light versus no natural light. What's the effect? Natural materials versus artificial materials. What's
so wood,
the effect?
plastic.
Wood versus plastic or laminate. Or what is the effect of having imagery on the walls of people from diverse backgrounds versus, let's say, all white men? What would be the effects? Research that's been done here at Stanford and other places would lead us to believe people would feel they don't belong. So we're actually trying to build the scientific basis to measure these things carefully. But then in the future, imagine buildings where we might notice that Russ is stressed out. How might we adapt his environment dynamically to change that? And how do you do that in a non-creepy way? You know, we don't want to be the paperclip of buildings. Right. Do we just make it such that Russ can notice this and easily put on his cool jazz and turn the lights down? So that's part of the research.
It's not unlike the very first thing you said about the flowers growing on my iPhone, but now you've abandoned the iPhone and it's the entire environment that I find myself in, cueing me perhaps in directions that would be better than other directions.
Exactly. So it's going to be this ambient awareness of not just the imagery on your phone, but it could be the large displays that are going to be on walls because they're going to be ubiquitous due to the cost. It could be the light, it could be the air flow, it could be the sound, all of these things. And so we're trying to look at what would that future be, but can we do it in a privacy-preserving way so that people don't feel like they're just being tracked and surveilled by their boss? So how do you balance those issues is key to our research.
Thank you for listening to The Future of Everything. This is Russ Altman. If you missed any of this episode, listen anytime, on demand, with the SiriusXM app.